And I think we are going live. Let's see. Yeah, it looks like Twitch is the last to come on, so we should be okay. Okay, cool. Hey everybody. Thanks. I am starting another stream, and this again is a data science live stream where I'm going to be doing some coding on a Kaggle data set. Let me show you where we were last week when we left off. So I've got Brave ready to open up my Jupyter notebook. And what we're going to do is show, let me see, where is Visual Studio Code on here? And, okay, cool. Oh, double clicked on accident. So when we hide Brave, we should be able to see Visual Studio Code. And we're going to make this full screen, and then we're going to make the text legible. We're going to make the text legible for you, because I know the stream is only at like 720p. So where we were last time is that we had actually, so we actually finally created and linked the local Git repository to GitHub, and we created the requirements.txt from the environment, the virtual environment made for this thing, and we calculated the sum of the stats and did a double check to make sure that the data given was actually correct, and it was. So that actually solved some potential problems for us. We did find a chart that we could possibly use to help us make something cool out of this data, and then also save the picture to the local repo. More complicated is there's this dual type chart, and not entirely sure how to incorporate that, but we've got it ready just in case. And the things we noticed were that the generation number that's included in the Pokedex data, gosh, shame on me. I should actually show you the, once again, I should show you the Kaggle data set that we are working with. So I'm going to load it up here and display it in Brave. We'll hide Visual Studio Code for now. So this is the Kaggle data set. Let me put that in the chat so that if you are curious, you can actually, you can play with it yourself. Nothing's really stopping you, I guess. Yeah, so I've sent it in the chat. And I just think this is a fun data set to work with. As you can tell, it's a super, super small data set, but what we're doing with this is, what can we actually make that's kind of fun or useful for whatever. Plus, like, it's kind of easy, right? Like, what can we make that's actually useful for either us or for other people? So in my kind of downtime, I started actually playing Pokemon Go, which is honestly bad timing because we're all stuck inside. And I have forgotten / I don't know what some of the types are effective against. So having some sort of comparison chart would actually be useful for me. And I just think it'd be fun. We could easily work with a larger data set, like one of several gigs, but on the first day when I was doing this stream, I thought it would actually make for an extremely boring stream to download something like, we had also downloaded this 1 gigabyte bird identification data, which was like, it looked really cool, but also it's just like, I ended up downloading it and then working on the Pokemon set while the download was happening. And it was just like, okay, we waited like 5 minutes just to watch a progress bar. There's new stuff up that might be pretty cool. If you've never done any Kaggle dataset stuff, they're pretty fun. The data is usually pretty clean. There is an indicator to talk about the quality of the data. But yeah, for the purposes of this stream, the only restrictions I had were no COVID stuff, because that is kind of too stressful, I think, and I wanted this to be kind of fun in case people were tuning in. And also, I wanted to make sure that it was kind of easy to use for everybody. So this is pretty good. This Kaggle Pokemon set, just super simple to work with. And it gives us the ability to maybe work on another project pretty soon. And yeah, so where we were from last time again. Let me go back to Visual Studio Code because we kind of got our checklist and stuff in there. So let's turn off Brave. We kind of playing with it. Again, I should rewind, actually kind of a bit back. So my name's Aaron. I'm a data scientist. Um, this is the third time I'm doing this stream, so it's kind of rote for me, and then I keep forgetting all the basic generic stuff. So yeah, I'm a data scientist, and I'm doing this live stream because it's actually kind of fun for me to get back into code. I'll be honest, I'm like in the middle of a job search, so a lot of times when I'm working on projects, I can kind of get lost and be working on other stuff instead. So having this time stream here is really nice because it actually forces me to work on something related to data science. And I think it's fun to try to teach people how to do this stuff, because like honestly, it can be hard to pick things up, but if you just keep trying, you never know what you're going to discover. That's actually how this data set turned out to be so interesting. I was figuring like less than 100 kilobyte CSV, it's going to be super boring and super fast to work with. But as we've done the exploratory data analysis in Jupyter, or Jupyter Notebooks, it's kind of revealed that you can actually do kind of a lot of stuff with just the Pokedex entries, and it even introduced some potential problems that data scientists might run into. So yeah, welcome to the stream if you're watching. I really appreciate it. If you have any questions, feel free to ask in chat. Again, this is like stuff for me to work on and then stuff to hopefully teach. Eventually, when this project runs out, I'm probably going to do something maybe related to data engineering. On the docket, I have like building a PySpark cluster, which would be, building a Raspberry Pi distributed computing cluster. And I have all the pieces, and I just like keep forgetting they're there because I just keep focusing on other stuff. So maybe next week I might actually do that just because it is set aside time where I have to be working on this kind of stuff. So yeah. Anyway, so things we found in the exploratory data analysis was actually that there are some nulls. There are actually a lot of nulls because the second type for some of these Pokemon shows up as a null, which is going to be a problem. You can't just drop the null entries then. And what the other things we found were that there are other alternate forms of some of these Pokemon, and they are included in the Pokedex. So I think there's 800 entries, and there's only 721 uniques. So this is going to be a little bit complicated to try to deal with those because when I was looking through, let me actually open up Jupyter Notebook for you. So what we ended up doing, if I can hide that. So I've rewound a little bit. I've changed, moved into the directory that we're working in. I have moved into the virtual environment that we created just for this project, and I am showing that we activated the environment. I probably shouldn't actually have this whole list ready. And we actually did do a git status, and it says everything is clear. So let me actually clear this out. And what we're going to do is we're going to actually do a git pull. So git pull origin master, because we pushed everything to the cloud, and we're not sure if maybe things are different, but we just want to make sure that the local copy and the online copy are already the same. And in this case, they are. They're already up to date, so we don't have to worry about that. So for today, we are on, what branch are we on? We're in git status, second EDA. Well, it's the third day, so why don't we make this third EDA? Maybe we don't even need to do EDA. Let's do something maybe a little bit more complicated. So earlier today, slash maybe yesterday, I actually randomly had a thought of like, well, if we want to take this data set and we want to show maybe like what would be a good Pokemon to use against other types, or what ones should you watch out for if you encounter them in trainer battles or whatever. And originally I was going to make something a lot more complicated, I think. And then I realized earlier today, like, it's just multiples of 2. It's like if you're super effective, it's double. If you're not very effective, it's half or 0, depending on the type. So why don't we just make some sort of function that lets you say like, okay, you've got what number index of your Pokemon. And then we can say, let's give you back what Pokemon it would be good against using those multiples, the 2 and the 1/2 and the 0. And then just give you, let's see, display like maybe the top 5 Pokemon that you'd probably see, or that would be either you'd be good against or weak to. matched with. Maybe those can be random. Actually, why don't I write those down? So normally when I'm working through some of these problems, I try to have a piece of paper around and just write down my thoughts. I also, in case you didn't notice, I like to have this little die here. Not little, actually. It's a foam die I got at PAX West when I was up in Seattle. And it's just kind of nice, like gives my mind ability to think and talk out loud if I'm on stream, and also distracting my hands from doing something else. So yeah, so what we've got written, what we can write down, go back to Visual Studio Code. So if we go back to things we want to do, let's get rid of display capture. Cool, so it's just Visual Studio Code now. What we can do, so let's make a new heading. Today is 2020-05-13. Wish list, let's say. Wish list, and please forgive all the typos and stuff you're going to see. This is a coding live stream, so you know nobody's perfect. Let's say we want to show. What we want to do is take the damage modifier. So wish list. Let's say we want to user inputs the Pokedex number. Then what we can do is incorporate damage. Well, I cannot spell today. Incorporate the damage modifier. Well, okay. Let's go back down a little bit and think about how it's actually going to parse through things. So user inputs the Pokedex number. Function parses the data frame to find the Pokemon with that index in the Pokedex. So if we write out what that would involve, it would say in user inputs 1, the data frame should find Bulbasaur. I believe that's Bulbasaur. Then incorporate, yeah, let's do it that way. Incorporate the damage modifier and find Pokemon that the input Pokemon is good against, bad against, and say neutral. So how can we incorporate this? Well, we know the damage modifier. We'll have to look this up actually, but I thought it was. So I think in Pokemon, the attack is calculated. Let's check. So check how stats are implemented to calculate damage. I thought it was 2 times the attack stat times the typing, which would be same type attack bonus. Times the strength of the attack. Minus the defense of the defending Pokemon. Since I am not entirely sure what's going on in terms of how the damage is calculated, we're actually going to look this up soon. But one of the things I want to write in here is that the move type that we're thinking about, since there's no way to incorporate with our data set, there's no way to incorporate the move type with the move power into this equation. What we're going to do is basically just assume that it's a multiple of the base one, which I think is, let's just say it's 50. It might be 100, but I think 100 is actually really high. And then for the same type attack bonus, we're just going to assume that the given move that the Pokemon wants to use is of the same type, so we will automatically apply the same type attack bonus. We could alternatively just remove it, and maybe that's better. It doesn't really matter, but if we wanted to make a more accurate damage calculator, we would have to incorporate the same type of attack bonus, so that's kind of why I feel like it should be included. So let me write down that in this case, the data set is missing the library of moves. So we cannot determine the actual move power or move typing. This makes us unable to use the true power to calculate damage or factor in stab. So let me put here stab is that. So we cannot calculate determine the actual move power. In lieu of these stats, we will assume the same move power for each Pokemon and assume that the move will have stab applied. So things I remember, the move tackle is a normal type, so technically things like a Rattata would get the stab bonus. But Bulbasaur would not because it's grass poison. So these are kind of like, we're giving a little bit of a damage boost, but I think it's fine. The other thing to recognize is how do we factor in dual types? Okay, so with all that said, we have that written down. What we're going to do now is we're going to start Googling stuff, right? So I'm sure it's like not the most fun thing, but a lot of this is trying to become my impression of what data science is you're also mixing in expert knowledge. So in this case, like, I don't know the actual stat to calculate the damage, so of course we have to look it up. And it's bad to assume it because you could just be wrong. And there's nothing wrong with being wrong necessarily. You just got to go back and correct it, right? So let's go back to Brave, and we are going to look up how is Pokemon damage calculated. Pokemon damage calculation. So we just want to make sure that this is correct. Okay, cool. And this may have changed in different generations, so we just want to be sure. Factors in the level. Okay. So as we can see here, let me see if I can make this bigger for you. Okay, so damage, except for moves that deal direct damage. Oh, that's the other thing. Let me write that down. Go back to Visual Studio Code or hide Brave, and what we're gonna do is Pokemon is such a complicated game when you actually look at the mechanics. We're gonna say ignore abilities, held items, and direct damage for this MVP. And the reason why is because abilities can really change some of the stuff. I know my brother was talking about how there's one ability, my brother and one of our Pokemon Go friends, there's one ability that makes Pokemon float, which makes them invulnerable to ground. So that changes a lot bad thing is if you've got an electric type, which is normally weak to ground. Held items can also change that because they can influence the stats and stuff. So we're just going to ignore all those and assume that like this is just plain vanilla regular Pokemon. And there's nothing kind of being affected by this. So let me save. And then since I saved, I think a good practice is actually to kind of git commit as often as you can. So we already saved, so I figure like what is our git status? Well, it should have changed the markdown file to readme, so let's just add that and commit it and just make sure that that's actually ready, because it would be kind of annoying if my computer crashed again and we lost this like little to-do list. Let's see, add to-do list. Oh, what branch are we on? We are on the wrong branch. So git checkout -b. Let's say we're going to add damage calculator. Add damage calc. So now we are in a new branch called add damage calc. If we look at the git status, we still have the modified readme. So we're going to git commit with a message, and we're going to say begin. Let's see. We're going to say add to do list to readme for damage calculation. Cool. And we're going to push that up to GitHub, git push origin. And we are on branch, add tab, add underscore damage underscore calc. Cool. So I'm going to have to enter my password, so don't look. And that is pushed to GitHub. I can do a pull request. Why don't we actually go ahead and do that? GitHub.com. And we are on. Oh, let's go back from display capture and show just Brave. Okay, so you can see here there's a compare and pull request. We're going to look at the pull request and we're going to say, okay, it's trying to merge add damage calculation into master. I am the person who made this pull request. Add to-do list, blah, 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 check out the changes, cool, everything makes sense because I just did it. We're going to allow the pull request to happen, then merge the branch, and then delete it so it's a little bit cleaner up top on GitHub. So we go back to code. We can see that we have added this new section from today. Yeah, May 20th, or wow, May 13th. Yeah. And for people watching, like, if you have any questions, feel free to ask. I'd love to hear from y'all. Otherwise, I'm basically just working through this problem and just talking about what I'm doing. If you don't mind that, feel free to, I guess, sit around. So we are going to hide Brave because, oh no, we need Brave. We are going to look at the damage calculation. So we go back to here, and we can see that it is calculated by 2 times the level divided by 5 plus 2 times the power times the A over D. All that divided by 50 plus 2 times the modifier, where the modifier is target. Wow, that is, wow. This is a lot more complicated than I thought it would be. It's just simple algebra, but I didn't realize that there's so many things that go into effect when you're trying to calculate Pokemon damage. But yeah, like for example, weather. I completely forgot about weather. Target. I forgot that you can do 2v2 now. So this is like totally different from all the stuff I really remember. So we're gonna start adding this to the to our code. At least into our README, just to make sure that we have it somewhere. While we're doing that, I'm also going to open the Jupyter Notebook file by typing Jupyter Notebook. So we're going to add this to the Jupyter Notebook. Once we get the server running, and then actually add the directions to um, calculate the damage output, and just have that ready for usage. So we go back to Brave and enter the address for the Jupyter Notebook. So we are here. We're going to go into Python, open the Kaggle IPy. I just want to be clear that like normally, so notebooks are great for doing this exploratory data analysis and just trying stuff, but normally I would actually prefer to kind of do a little bit of testing on here and then committing everything to actual Python code. This is a thing that I learned when I was in the boot camp, because it's like, yeah, it's cool to do this in the notebook. It's really easy to see the results, but like it is kind of annoying and pretty difficult to repeat your experiments and stuff by just leaving things in the notebook. And especially like when the notebooks actually get bigger, they'll actually like you'll see like hundreds of cell activations and all that kind of stuff, and it's just not clean. So usually in my workflow, what I prefer to do is to get things tested in the Jupyter Notebook file, transition over to just doing regular Python scripts, and then what the heck is in the background on the stream? Transition over to doing just regular Python files and scripts, and then outputting any graphics or anything into a Jupyter Notebook. I think that's a lot easier to see. And then from the notebook, like link to different things in the repo in case people want to actually see what's going on. So yeah, cool. So for example, we actually don't need the, from last time, we did this imputed calculation total, and it turns out we don't even need that anymore. And see all of these things on the side that are set to like in and then a number in brackets, that means that somebody like, we've run the cell and it's just displaying that, but some of these we don't need. So I think what I'm going to do is I put this nice divider in here before to signal like where did we stop, I guess. So I'm going to do something similar for today. I'm not sure why it says type markdown in LaTeX. That's weird. Let me just delete that. Or maybe it won't delete. Interesting. The computer didn't freeze. Okay, cool. So put in a new cell, and then what we're going to do is Pokemon, make this a markdown cell. Pokemon damage is calculation, and then from, I'm going to say from Bulbapedia, is damage equals 2 times level. Damage equals 2 times level divided by 5, and then plus 2. 5 plus 2, and then that's all in a parentheses. So that's the first term, times the power, and then times the a over d. So times power times a over d, and then all of that is over, there's going to be a lot of parentheses in this equation. All of that is over 50. And I have the plus 2 in the wrong spots. No, there's another plus 2. Okay, so all of that is over 50, and then there's another plus 2. And then that is also in parentheses. And that is multiplied by the modifier, where modifier is modifier. Cool. Let's try to tidy this up a little beforehand, or a little after. So A equals, A is the effective attack stat. If The move is a physical move or the effect is a special attack. Okay, so in this case, let's go back to our data analysis. So we do have special attack, special defense, and attack or defense. So I would say instead of using I don't know why they didn't just say effective attack, where A is the move's damage typing, not typing, move damage moves stat base attack or special attack. And D is the defending Pokemon defense or special defense. I believe that's what that Bulbapedia says. So D is the effective defense stat of the target. If the used move is a physical move, yeah, cool. And then the modifier is targets times weather times targets times weather times badge times. I didn't even know the badge plays an effect. Oh, generation 2 only? Wow. Okay, cool. Critical random stab. Critical random stab. Type, burn, and other. Type, burn, other. So what do those mean? Targets is 0.75 with multiple targets and 1 if solo target, 1v solo target. Weather is 1.5 if it's a water move used during rain or fire type during harsh sunlight. 1.5 for water in rain or fire in harsh sunlight, and 0.5 for water in harsh sunlight. Or fire type during rain. Otherwise, just 1. And then we have badge, which is 1 now. Badge is applied in generation 2 only. It is 1.25. Yeah. Badge equals 1. Feature dropped after Gen 2. Stab is the same. Oh, let's see. Critical is 2 for. Critical is 1.5 from generation 6 onward. Oh, that wording is. The wording is kind of confusing. So the critical, if you get a critical hit, it's a 1.5. I think that's what they should say in the current generation. Maybe I should do a pull request on the wiki article. Critical equals 1.5 if the attack is a successful, full crit. Random. Random is a random factor between 0.85 and 1. Okay, why? From generation 3 onward, it is a random integer percentage between 0.85 and 1. Okay, it is literally a random number. Wow, okay. Random random number between 0.85 and 1.0. Definitely need to touch up this article because like you can't have a random integer percentage between 0.85. Like they're not integers. They're not whole numbers. Stab is same type of attack bonus, and stab is 1.5 if the moves type matches any of the user's types, and 2 if the move additionally has adaptability, 1 if otherwise. So adaptability is an ability, so we're not going to use that. So 1.5 is 1.5 if move type matches Pokemon type. Otherwise, 1. And burn is 0.5 if the attacker is burned. Oh wait, type is the type effectiveness. This can be, oh, this is the damage modifier I was thinking of. This can be 0 if the move is ineffective, 0.25, 0.5 not very effective, and it depends on both the move and the target types. So, type, I don't know why that's called, I guess because it's effective, yeah, I don't, so it's either 0, 0.5, 1, 2, and 4, I think. Yes, 2 or 4, depending on matchup. Okay, so that is, other than 0, oh wait, no. Yeah, those are all 2 to the n, where n can be -1, 0, -1, 0. Oh wait, that's not factoring in the 0. Okay, well, we'll figure that part out. It's either 0 or some multiple of 2, like I said earlier. And then burn and other is just going to be 1 because those are dependent on abilities or items. So that's easy. Same with, we can drop badge, and we're going to ignore burn. Okay, so let me write that down. For our purposes, ignoring items, abilities, weather, and badge, we can make badge what else was there? Burn other equal 1 for the multiplier. I am surprised by the, oh, actually, and we're also going to make crit equal to 1 and just assume it's not a critical hit. Equals to 1, and weather. So we reduce down to thus modifier reduces to, oh, and targets. We actually have a lot of simplifications in this, so that makes our data analysis a little bit easier. To random thus modifier equals random, almost wrote ramdon, which made me think of Parasite, and honestly, it's 7-Eleven. I am kind of hungry, so ramdon sounds kind of good right now. Stab type, and then that's it. So how can we figure these things out? So we need to figure, also, and stab, we're just going to assume is equal to 1.5. We're going to assume that the move that we're using is of the same attack. So stab equals 1.5. So that would be 1.5 times random. Make things, because I never really liked numbers just randomly being among the words. So modifier equals 1.5 times random times the type. So we need to figure out, how to get random and how to get type, which is the multiple of 2 effect. Okay, cool. So let's enter that. Is not the prettiest thing. Also for our level, actually, we are going to also, we need to make an assumption on the level and the power. In this case, we need some stat to use to define power. The A and the D will be specified. Actually, since we don't have the move type, the attack and defense is actually kind of a thing we should worry about. Okay, so in this case, like for the attacking stat, for our purposes, also let's use the bigger of attack or special attack. Let's use the bigger of attack, special attack, and defense, special defense for A and D. Okay. And for power equals, let's just make it 100. Power and level both equal 100 for our calculations. Because I also think that the stats that are given here are the, let's go look back at the data before we assume anything. These are the raw attributes, the attack, the base modifier for normal attack, special attack, the base modifier for, but does this answer, this is kind of fun. It'd be worthy to find out which 2 variables can define the type of a Pokemon, if any. So there's actually some challenges in this Kaggle challenge. One thing I am not sure of is we want to know what this stat number that we're using, the HP, the attack, the defense, special attack, etc. We want to know where these stats are actually recorded. So are they like level 1, are they level 50, are they level 100? If we know the level and it's consistent throughout everything, then we actually can just plug in the level inside that equation rather than assuming everything. So if we go, let's say we go here, and it's another Pokedex, Bulbapedia entry. So this is just listing the Pokedex, so that's not going to help us in this case. If we go to Pokemon DB, and I guess also Pokemon.com, about Pokemon stats. Every Pokemon, yep. Cool. What we can do is, given this, let's open that Bulbapedia Pokedex given this, right, we can try to figure out if we click on the individual one, it should tell us the stats and then also what level those stats are recorded at. So in this case, let's see, stats. Stats. Okay, base stats. So base stats are at level 1. Yes. Let's look this up. Pokemon base stats. What level? What are the base stats of the Pokemon? So I guess one of the hard things is that when these Pokemon level up, it depends on what kind of effort values they've undergone. So that's why if you look back at this entry from Bulbasaur, it will give you a range, and it's because if you have been doing any sort of leveling up, it's going to be different depending on what effort values you actually have been focusing on. So we can assume that, let's just assume that it hasn't been EV trained because those EVs actually make kind of a big difference, and that is outside the scope of our data, and you can probably assume someone who actually cared about getting the max EVs and IVs would be much more concerned about that, and we can make something for them later, but as a minimum viable product, this is probably not the best thing to use. How are base stats calculated or assigned? Species strengths, commonly referred to by fans as base stats, are the inherent values of a species or form of a species that are unique to used to the stats of the Pokemon. Oh wow, okay, that's confusing. Species base stat, etc., etc. Yeah, I guess that's at level 1. Okay, so we're just gonna write level 1. Let's go back down here. Let's say power equals 100. And level equals 1. So that actually allows us to fill in the whole equation. So we've got the level, we've got power, and we can find AD and also the modifier. So rewrite equation. So we've got damage equals so many parentheses. Let's see. Oh, let's just copy this over. So we've got 2 times the level. We've made the level 1. So just 2, and that means we can remove one set of parentheses to make it a little bit cleaner. So we've got 2.5 plus 2. So let's just simplify that, and that would be 2 is 2 and 2.5. So it's 2.4, or we can just keep it as a fraction, but it's 2.4 times the power, which we're going to assume is 100, times the 100, not 1,000, times the attack, and then divided by the defense. All of that divided by 50, and plus 2, and then times the modifier, and the modifier is 1.5 times random times type, where type is either 0, 0.5, 1, 2, or 4. Cool. And then type would also depend on if we are playing Pokemon Go, because the 0 not effective attack type is actually not in Pokemon Go, which is kind of cool because it allows more Pokemon to be viable. Let's see. So if we simplify this more, this would be 240, whoops, 240 times the relevant attack stat over the damage, or over the defense stat, divided by 50, all that plus 2. So let's make this another, because of the properties of multiplication, we can do something like this. Just make things a little bit easier to understand. Let's see, so we got 240 divided by 50, that times A over D, and we've also got that plus 2, and then times 1.5 times random times type. So we need to figure out how to get random, so we are actually going to have to import math to get random, and then we can set the range on random from 0.85 to 1 inclusive. So this is pseudocode right now. Inclusive. How to get type, which is the multiple of 2 effect. So for that we can do, we can compare the entry, the attack inputted Pokemon type against the defending Pokemon type. And then if it's, we can multiply the, what we can do is, so why I'm hesitating now is if I just use the type and compare it against the other, what we might accidentally do is double where it shouldn't be doubled. So let's say we have, what's a good one? We have got fire fighting, right? So we've got a fire type Pokemon that's also fire type, fighting type. So that could be Blaziken. It could be, I think, Incineroar. So if we have those types and we're attacking something that is grass dark, like Shiftry, if we do that wrong, the move can only be one type. But if we put in the how it would calculate the 2x incorrectly, what we might accidentally do is we would have a fire fighting move counted instead of just a fire or just a fighting, and then that would be used in the multiple against the grass dark. So if it accidentally did 1 2 times for the fire, 1 2 times for the fighting, that's 4 times effective. And then if oh wait, no, that's fine. So there, that it would be bad to have the 4 times effective, but what we're actually doing is checking individual types against the defending types, the defending combined types. So that way we can actually factor in everything. So if you had a fire move, you would use that the first move, first type in our case, because we don't have move types. So we can pick either type for a dual type Pokemon and either compare them to both types of the defending Pokemon. So if we have a fire fighting move, we can use either the fire or the fighting type and calculate it against the combined effect against against grass dark. So dark is not affected by fire, so that's a 1, and the grass is weak to fire, so it would be a 2. So the effective multiple would be 2. Okay, let me write that down. Compare the Pokemon inputted Pokemon type against defending Pokemon types. For dual types, these are multiplied together on defense. So what that means is, I know this because they're pretty popular in Pokemon Go. There are Pokemon that are water ground. So when they're water ground, normally water is weak to electric. So they would take 2 times damage against electric. But if they're water ground, ground is actually 0 effective, I think. So electric, I think, hits ground for 0, if I remember correctly. And that would mean that it actually hits those water ground for no damage, like because the 0 would override. So we can check both and then assign a temporary. Assign one. Assign the damage effectiveness for one type and multiply by the damage effectiveness for the second type. Assign damage effectiveness for type 1, then multiply against type 2. I wonder how that logic will be incorporated. Yeah, okay, we'll get to that. So the random is actually pretty easy. The type might actually be a little bit harder than I thought to incorporate. That's cool. Let's see. And what we want to do is, since we're trying to suggest Pokemon that you have chance against, what we can do is organize. So after we've got the damage reported from this, we can store that in another data frame maybe, and then just have the sort from max to min of damage inflicted. Display top 3, top and bottom 3, and then display top and bottom 3, and let's say also the middle. Middle and bottom 3. And then the top would represent things you are capable of doing a lot of damage against, and the bottom are things that you're probably going to have an even split. The middle are the ones you'd have an even split against, and then the bottom 3 can be the ones that you definitely want to avoid, because you are not going to do a lot of damage to them, and it very likely will mean that they are going to do a lot of damage to you. Okay. Then what I can do is repeat calculation for defending Pokemon versus inputted type. Let's see. Sort for maximum of damage inflicted, and sort, and then we're going to do another thing, sort from max to min of damage received, and display top, middle, and bottom 3. And that might actually be kind of interesting because there are some types that are like super effective against itself. So dragon being one of them. So you might want to watch out for If you are a dragon type, let's say dragon flying, like Dragonite, you'd probably want to watch out for other dragon types, especially ones that don't have the same weaknesses you do. So dragon flying, I think, is very weak to ice. I think that's the only one. But there are some dragons, like I think, I can't remember their names. I think there's one that's Dialga, and that one is part steel, so it ends up being like not weak to. Oh, dragons are also weak to fairy. I forgot about that. So they're quad weak to ice and double weak to fairy. And if you have Dialga, it is no longer weak to fairy because it's part steel. Yeah. Okay. Cool. So this gives us like kind of a lot of things that we can possibly add to this data set. We've been working on this for like an hour. Okay. Let's actually kind of want to take a break, get some water, maybe stretch my legs a little bit. And figure out how to actually incorporate this stuff. Let us say that we. Well, first, the easiest one is we're going to need to get math. We're going to need to get math in for random. And let us look at Python math random. We just need the documentation. So generate pseudo-random numbers. This is Python 2. So another thing, if you're Googling for documentation, especially for Python, make sure that you know which version you are on. So version 3.8 is the current one. 2 has been discontinued. Don't use 2, just don't. So this generates pseudo-random number generators. We don't really need a random seed because every time we try to test, it's going to be curious to know, and we can use random. Just call the method without really needing to specify the seed because if we run it for the our Pokemon against the defending one, we don't need to preserve that seed number for the other way around. So yeah. Random.seed, we don't need that. Rand range, that's the one we want. Return a randomly selected element from range start stop step. This is equivalent to choice, but doesn't actually build a range object. Good. So the positional argument pattern matches that of range. So steps, in our case, we actually probably just want to keep it to 2 decimal places. I think that's honestly what they meant by like a whole integer random number between 0.85 and 0.1, or sorry, and 1, because they didn't list other digits. So we are going to need this random.randRange. We don't really have a sequence. We don't need a shuffle. I don't think we need actually most of these, although these are good for stats. Alternative generator, notes and reproducibility. Okay, cool. So we are going to have to import math, and I believe, let's look at their example code from random. Okay, we don't need random. We don't need math. We need random. Okay, so from random import, I think we can just import random. From random import random. Yeah, I think that might be it. Rand range. From random import rand range. Okay, so let's write that in. From random import rand range. Oh, we're gonna have to. Okay, so let me clear everything. And I think I'm also going to mark out the cells that we did last time that we don't need. I will change them over to Markdown code because we don't really want to run them as regular code. So we've imported the libraries. We're going to import the data. We actually don't need to describe it, so let's turn that into Markdown, and then turn this into Markdown. Actually, you know what? We might need this as just in case as like a fact check later, because I think it also displays the mean. Yeah. Okay. So we might kind of need those. So we don't need this section because it was just playing around. So let's all turn all of this into Markdown just so we can have it, and then check it later if we really need it. But I kind of doubt it. Okay, cool. So we're now back to our base data set. What we can do is we want to generate a random number. That's really easy because now we've got it, right? So rand range, rand range, right? Rand range, 0. Yeah. Okay. So what we're going to do is rand range, and we're going to start at 0.85, go to 1.0, and then the step is going to be 0.01. So I think it was start, stop equals. Let's double check. You don't have to do these explicit calling it like this, but I think it's kind of nice and might as well. Oh, hey. Non-integer argument 1 for rand range. Why don't we return the random? That's weird. I wonder why it's doing that. Well, let's see if we just do this, right? It says it's based off of range. So if we just do this, float object cannot be interpreted as an integer. Okay, cool. So what instead we're going to do is we're going to do a trick, a kind of dumb trick. We're going to go from 85 to 100 and then make a step of 1, and then hopefully that'll work. Yeah. So if we keep doing this, it should give us a random number each time. And then afterwards, we're going to just divide this by 100. Look at that. It worked. I kind of wonder why it didn't just let me do a something between 0 and 1, but hey, whatever. This works for now. I'm sure like I can find something later to make this a little bit neater. So we're going to say random rand mod equals that. And we'll just get it ready in case we need it later. Actually, we don't really need to store it in memory, I think. Because we're only going to, since we would test it against other Pokemon in the database, we actually don't need to store it because it can just run every time, since it's a different attack each time. Okay. Well, it's just good to have that ready. I'm not going to change that for now. So we've got random. That's good. How to get the type, which is a multiple of 2. So we need to get a list of all of the types as they're recorded in the data, because maybe there's a typo and we don't want to just record the wrong thing. So let's say df type 1 dot unique. Cool. And then df type 2 dot unique. Okay, so the only thing we have to worry about is the nan. I want to store these types into a set. And we can actually just use the just use the type 2 because there should be the same number plus 1 in type 2 because of that nan. Let's test this out. df type 1 dot the shape because it is an array. Okay, cool. I tried. df type 1 dot describe. There are 18 unique items for 800 rows, and we'll do the same thing below. Unique. Oh, I forgot. Oh, okay, yeah, that makes sense. There are still technically like 19 because of the nan, but this count is different. So now you can actually see if we'd actually dropped all the nans, we would be losing about almost like 400 Pokemon. So that's like half the data set. So obviously not good that we wouldn't be able to just drop straight away. Let's see. What we can do now is let's think about how we can incorporate. There's got to be a way to export the ND array. Yo. Sure, if you want it. Yeah. There's got to be a way to export the array. So we have an ND array, and we want to turn it into to set. Stack Overflow. How to turn a NumPy array to set efficiently. How can I remove unique elements? Let's see. Let's not do that. Constructing a Python set from a NumPy matrix. That's probably, yeah, I thought there was a ND as type, so you could convert it over. Let's see. So ND array. As type. Cool. Copy the array. Cast to a specific type. You done with D&D? Yeah. Oh, okay, that was fast. Yeah, we did something else. Oh. Okay. Well, I'll probably call this stream in like 15 minutes then. Because I'm also getting really hungry and very scratchy throated because I've just been talking for the past like 2 hours. So yeah, okay. So we want to cast to a set, and then if we cast to a set, we can basically just see if the type is in the set, then we can assign a damage modifier. So ND array as type. Let's see how to do that. We're going to do df type 1. All right, df 2. df type 2 as type set. And it has to be a string. Oh, wait, or data type. Okay, so let's give this a try, and then if it doesn't work, it will give us an error, yeah, just like it did. So dtype class set. I wonder if it's because it is actually trying to convert everything in the array into that type, which is definitely not what we want it to do. Casting between a simple data type and a structured one is possible only for unsafe casting. Casting from numeric to string types in safe casting mode requires that the string data type is long enough to store the max integer. So I think this is not actually what we want. Turn the Huh. Yeah, this is super fun. We don't want to string. There's actually apparently not a method to do this. Okay, cool. I guess if I had done list, let's see. I don't think it could do this either because that is a non-simple type. Yeah, cool. Okay, so that couldn't work. If we take, I'm pretty sure I've gotten something like this before, and I got it to work. What we can do is set field, standard, swap axes to list. That's it, to list. Um, so if we do to list, and we can actually put that in a set, which is kind of silly, but hey, that works. To list, parentheses, cool. And then what we can do is put that whole thing into a set. Yes. Okay, cool. So that worked. And we can call this set like all types. Types equals, and then we'll have it redisplay all types. Cool, 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 cool. What else can we do? So, we need the damage modifier so that we can actually do some multiplication. So we need to know the relationships between all the different types. This is going to be maybe kind of time consuming. Okay. So if so I'm going to write some pseudocode just to get my thought process down. So if type 1, so if input Pokemon type 1, how can we do this without a very complicated series of if statements? Basically, what I'm realizing is how if we were to do ifs, it would check each type of the Pokemon, both in the first one and the second one. And then for each type, so for for Pokemon, input Pokemon. So it is not a for loop, but type 1. So let's say if input Pokemon type 1 equals fire. So we actually didn't really need that set. Then, so let's have damage mult equals 1. If input type Pokemon equals 1, what we can do is make sets of the weaknesses. So make sets of weaknesses and strengths for each type. So for fire, strong against, the set would be bug, grass, ice, steel. Let's look at the Pokemon type chart again. Cool, accept the cookies. Here we go. So, where is fire? Bug, steel, grass, and ice. Hey, I got all four. Bug, steel, grass, and ice, or bug, grass, ice, steel. Yeah, so for fire, strong equals this. If defending Pokemon type 1 is in strong, damage molt times 2, if defending Pokemon type 1 is in weak, strong against, weak against equals be a set. Weak against rock, fire, water, dragon. Rock, fire, water, dragon. Then damage molt times equals 1/2. And let's see, not very effective. Oh wait, reduced against, let's say that. And then let's have another 0 against, and in this case it'd be empty. If defending Pokemon type 1 is in 0 against damage molt times equals 0. So in a worst case scenario, if fire was against a bug grass Pokemon, it should do 4 times damage. Yeah, and then cool. So this is where a little bit of the tedium comes in, because as I've written the pseudocode now, I would have to make individual sets for each combination, for each type. So this might actually be a good time to kind of wrap things up and add things to the to-do list for next time. And to be honest, I might actually code this up outside of the data stream, or sorry, outside of the live stream, because the tedium of this is pretty high, and you wouldn't be able to see the results. So what I might do is like try to write up these sets, get them going, and then show how they work next time. But otherwise, like, yeah. So let's go back to, we're going to go back to turn off display capture, turn on Visual Studio Code, and turn off Brave. Why is that minimized? That's weird. Yeah, cool. Um, wow, that's like way bright. Um, hopefully I'm not all blown out. But yeah, actually, yeah, cool. That's the brightness that works. Yeah, so for next time, for next time, pre-work is to code in the logic, um, show the code in the rough logic, show the results, um, and I think that's it. Um, update repos. What else can we do? Let's see what the pseudocode we wrote in. So the logic is kind of a lot. Um, and oh yeah, add this equation. Um, add equation for damage to get results. Show results of pre-work, add the equation for damage to get results. So yeah, honestly, a lot of this stuff is kind of tedious. So I could do the live stream with this, but with limited time, it's like, oh, I don't know if this is like such a great usage of stream time, but I don't mind getting on and talking to people and seeing if I can answer questions if people are watching. Otherwise, like, yeah, it's just me working through data science stuff. It could be that next week instead I try to actually build that Raspberry Pi cluster. That honestly might be a more productive usage of time. To be completely honest. Yeah. But if you'd like to see this or if you have other questions, feel free to send stuff and ask. Open to chatting. And yeah, if you think this would be interesting or helpful for other people to show what a data science workflow looks like with a simple project, feel free to send along this info to other people. I'm totally open to talking about it and hearing from y'all. But yeah, until then, I'm going to say that this is probably a good place to stop, and I will talk to you later. All right. Have a nice night, everybody.